Hello everyone and welcome back. In the previous video we have learned how to create a peer connection and our local stream and get ready to start a call with our opponent or with our target. So to do that I'll create two functions here. Let me close these functions. The first one is going to be an extension function using peer connection. The first one is going to be call, and as the arguments is going to take an SDP observer and target as string, and the next one is going to be another peer connection extension function called answer. It's going to have the same SDP observer and the target, just the same. But these two functions are going to need to interact with our WebSocket model. So I'm going to create an interface here and call it listener, and it's going to have a function called onSendMessage to socket, and the data is going to be the data model, and we're going to implement this in our RTC clients. So it's going to be a public var of listener. It's going to be RTC clients dot listener, and it's going to be null. So we remove this. So we're going to pass the objects or send our data model to WebSocket using this listener. So let's go back to our call function. To create a call, we need to create an offer. As you can see, we're going to need two arguments. One of them is the SDP observer, and the next one is going to be the media constraint. So let me create my media constraint here. Val constraint is going to be a new media constraint. I'll apply some key value pair to my mandatory from this class. So I'll add media constraints dot key value pair, and the key is going to be offer to receive video, and the value is going to be true. So after that we're ready to create our offer. So as the SDP observer, and create an anonymous class of type SDP observer, and as the delegate I'll pass my SDP variable, which I'm getting from my variables of my call function. As the constraint, I'll just pass my constraint to it. So here I need to override on create success method. If this happens, I'll create my local description here. So I'll set my local description. And as you can see, we're going to need two arguments, an SDP observer, which I'll create an other anonymous class here of type of SDP observer, and implement the member of it. And as the description, I'll get the description that I'm receiving from creating offer. So right here, after we created our offer and set our session description that is driven from this onCreate success to our local description, we are now ready to send our session description to the target. To do that, here in onSet success, I'm going to use my listener and send a message to socket, and the message is going to be data model, and the type is going to be data model type dot offer. the username is going to be the username that we have in our class. Target is going to be the target that I'm receiving from my function, and as the data we are going to use our session description and take its description. So let me go from top to bottom again. Whenever we want to create a call, first we have to create an offer using our peer connection. Whenever an offer is created, we are going to receive a description, which is going to be a session description. After creating a session description, we have to set this as our local description. To do that, I'll use the set local description function and pass it to my local description context. And after we successfully set our local description, we are going to send it to our target, and the target is going to use it as the remote session description. So let's go to the next function, which is answer, and it's going to be pretty much the same as the call. To do that, I'll create my constraints again, which is going to be a media constraint. Apply some data to it. So the mandatory dot add media constraints dot key value pair, and the key is going to be offer to receive video, and the value is going to be true. And after that, we're going to create an answer. So first thing that we have to pass to it is our STP observer. I'm going to create my anonymous class of type STP observer and use the delegation here and give the STP observer to it. It's like that, and as the constraint, I'll pass my constraint to it. And here we have to override on create success and rename this to description. And after that, we have to set local description again, just like the call function, and pass the description to it. And after we set our local description, we are going to send a data model using our listener class to our target, which the type of it is going to be data model type answer. The username is going to be username, the target is going to be target, and data is going to be description. So let's use this function from outside of our class. So I'll create a public function which is going to be call, and it's going to require an SDP observer and target string, which is going to use our peer connection and call it. So SDP observer and target. Pretty much the same for answer. So we are good to go to use this function. Right now we have done how to start the call or answer the call and set our local description, but now we need a function, a public one, to set remote session receive or on remote session received. You're going to need a session description, and using our peer connection we want to set remote session description, and as the observer we are going to pass anonymous class. You're not gonna watch what happens, and as the session description you'll use this one. I'll just implement these and don't do anything to them. After handling our session descriptions, we now need a way to set an ICE candidate to our peer connection and send it to our target. So let me create our functions. The first one is going to be add ICE candidate, and this one is going to need my ICE or ICE candidate of type ICE candidate, and using peer connection we're going to add ICE candidate to our peer connection, and the next one is going to be send ICE candidate, which also wants an ICE candidate and the target to send it using WebSocket. First thing to do, we need to add this candidate, which is generated by the turn server, to our peer connection. So to do that, I'll use the add ICE candidate function and pass it to it, and then we want to send it to our target. So I'll create an ICE candidate constant or data of the ICE candidate, which is going to be a hash map of stp mid to candidate.stp mid and stp m line index, and pair it to candidate stp m line index. Let me just copy and paste this to prevent mistakes, and stp candidate to candidate.stp. So our candidate data is ready to send. Then we use our listener class and send our data model. The type of it is going to be ICE candidate. The username is going to be us. Target is going to be target. The data is going to be candidate constant. So right now our WebRTC client is ready to use, but we need some few functions before we end this video. The first one is switch camera function, that using our get video capturer, the context to it. I wish I have created a video capture object instead of this 3 lines. So let me do that. Private video capturer is going to be get video capture using our context, and replace them just like that. Switch. This one has to be camera video capture, and here we can switch the camera. And the next function is going to be close the camera. Using video capturer, we stop the capture and then we dispose the video capture. And the last one is to close connection of our peer connection. To do that, we use a local stream to dispose the stream and then the peer connection to close. Okay, that's it for this video. In the next one, we will learn how to create our repository and use our RTC client and our WebSocket clients to interact with each other and to contact our targets. So that's it for this video. Till the next one, see you.